So the problem is find all pairs of one-digit non-negative integers a, b, c such that a and b are not equal to 0 and ab over bc is equal to a over c. And know that the ab with a line over it means it's a number with digits a and b. It does not mean a times b. So first we can write ab and bc as 10a plus b and 10b plus c. And then we can cross multiply to get 10ac plus bc is 10ab plus ac. And we can write that as 10a times c minus b is c times a minus b. So now we have to deal with a couple of cases. The first of which is if both the left-hand side and the right-hand side are equal to 0. Since c can't be equal to 0, because then we'd be dividing by 0 in the fraction a over c, we must have a minus b equal to 0, which would mean a is equal to b, and then here b would be equal to c. So this means that all the pairs 1, 1, 1, 2, 2, 2, all the way to 9, 9, 9 are solutions. So now the second case is if if both the left-hand side and the right-hand side is not equal to 0, the right-hand side also must contain a factor of 10. But since both c and a minus b can't be greater than or equal to 10 and can't also be less than or equal to negative 10, we know that c or a minus b must be 5, or a minus b can also be negative 5, and the other must contain a factor of 2. So the first case is if c is equal to 5. If c is equal to 5, that would mean 2a times 5 minus b is equal to a minus b. So that simplifies to 10a minus a is equal to 2ab minus b. So we divide both sides by a to get 9 is equal to 2b minus b over a. Since the left-hand side is an integer, 9, the right-hand side must also be an integer. So this means that a must divide b. Okay, so now we can factor the right-hand side, and that'd be b times 2 minus 1 over a is equal to 9. And we can write that as b over a times 2a minus 1 is equal to 9. Okay, so since a times b over a is an integer, is a positive integer factor of 9. So now we can test like cases here for b over a is equal to 1 through 9. So if b over a is equal to 1, we have that 2a minus 1 would be equal to 9. which means that A would be 5. And B must also be 5. So the pair 5, 5, 5 works. And if B over A would be equal to 3, then 2A minus 1 would be 3, which means A would be 2. And B would be 2 times 3, which is 6. So 6, 2, and 5. Oh, wait. 6, 2, and 5. What? Yeah, 2, 6, and 5, sorry. 2, 6, and 5 are also a pair. And if B over A is 9, we have 2A minus 1 is equal to 1, which means A would be 1 and B would be 9. So 195 also works. And note that 555 is already counted in these, so we just don't need that. So finally, oh wait, no, there's 2 more. Okay, so I'm gonna bring this down here. So for the case equals to 5, we found new pairs 2, 6, 5, and 195. So now if A minus B is equal to 5, then we would have 2A times C minus B is equal to C. And since A minus B is equal to 5, we can write this as 2A times C minus A minus 5 is equal to C. So 2A times C minus A plus 5 is equal to C. Okay, so note that A divides C. So since A divides C, we know that A must be less than or equal to C, right? Because they're both positive. And since A is less than or equal to C, we know that this part, C minus A plus 5, must be at least 5, right? It must be greater than or equal to 5. So this means that C must be greater than or equal to 10A. But C is a 1-digit non-negative integer, right? But since we said that C must be greater than or equal to 10A, well, that doesn't work because then it'd have to be a positive multiple of 10. So this means that there are no pairs for this case. And finally, for the last case, it's if A minus B is equal to negative 5. So that would mean that negative 2A times since B is equal to C. And so we can write this as 2A times 5 plus A minus C is equal to C. Okay, so again, A divides C, and they're both positive, so A must be less than or equal to C. And okay, so if A is equal to C, we would have that 10A is equal to A. And since A can't be 0, we would divide both sides by A and get 10 is equal to 1, which clearly isn't true. So we have that A is less than C. And since A and C are positive, this expression must also be positive. So the possible values for this expression is 1, 2, 3, or 4. Okay, so now if 5 plus A minus C is equal to 1, we would have A minus C is equal to negative 4. And so 5 plus A minus C is 1, so 2A is equal to C, so we can substitute that, and we get A is equal to 4, and B is equal to 9, and C is equal to 8. So 4, 9, 8 is a pair that works. And if 5 plus A minus C is equal to 2, we would have 4A is equal to C. And we have 5 plus A minus C is equal to 2, so A minus C is equal to negative 3. And so that's negative 3A is equal to negative 3. So A is equal to negative 1. B is equal to 6. And C is equal to 4. So 1, 6, 4 is also a pair that works. Now, if you try 3 or 4, we see it doesn't work, because then A minus C would be negative 2, and 6A would be equal to C, so negative 5A would be equal to negative 2, or A is equal to 2 over 5, right? And then 2 over 5 isn't an integer, so that won't work, and same goes for 4. That doesn't work either. So, those were all our cases. So, our final answer is that the pairs are 111, 222, all the way to 999, and 265, 195, 498, and 164. And also, we can check that these pairs work, because, for example, with 1, 6, and 4, we have 16 over 64, and 16 over 64, we can cancel out the 6's, and it's 1 over 4. So, yeah.